Hello everyone, welcome to this session on Pre-Algebra and Elementary Algebra. Did you know that in major US college admission tests like ACT and SAT, a large portion of math questions come straight from algebra and number sense. On the ACT, around 10 to 14 questions, which is about 1/4 of the entire math section, are based on pre-algebra. The SAT highlights these topics too, especially under the heart of algebra category. These are fast, reliable points if your fundamentals are strong. In this video, we will cover key rules, shortcuts, and problem-solving strategies to help you solve these questions quickly and confidently. Whether you are preparing for the ACT, SAT, or any other college readiness exam in the US or beyond, this lecture will be very helpful. We will focus on 6 key areas that are essential for building a strong math foundation. The first one, order of operation. Then we will go to fractions and decimals. Then percent basics. After that, we will move to properties of integers and absolute value, and then expressions and variables, and then finally solving some simple equations. Let us begin with the order of operations. Here a very important rule that you should always remember is called PEMDAS. According to the PEMDAS rule, whenever an expression contains more than one operator, you must follow a strict order to simplify it correctly. Start with parenthesis P and then handle any exponents E, followed by multiplication or division, and if in any expression you have both multiplication and division, then whichever comes first as you move from left to right, and then after that you move to addition or subtraction, again from left to right. If you have both addition and subtraction, then whichever comes first as you move from left to right, you should tackle that thing. Now let us apply this PEMDAS rule to this problem, which is this expression over here. Okay, and we will see that what is the correct way, what is the correct sequence in which you should operate over this expression. So let us begin with the parenthesis because P comes first. So what we will do, we will first do things which are inside the parenthesis. So here you have 3 and 1. So this will become 4. So we come to the 4. Now we will handle the exponent. 4 to power 2 is 16. So we got this number 16 over here. Okay. Now next comes in PEMDAS rule is multiplication. So we will multiply 2 and 16 together and we get 32. So now you have 6 minus 32, and now comes finally here we have to do subtraction. So 6 minus 32 comes as minus 26. So this is the right answer. PEMDAS, parenthesis, exponent, multiplication and division, whichever comes first. If multiplication is first, you do multiplication. If in any example division comes first, you do the division, and again as you move from left to right, and then addition and subtraction, again whichever comes first. If addition comes first, you do addition. If subtraction comes first, you do subtraction as you move from left to right. This gives you, all the time it will give you the right answer. On the other hand, if you don't follow the rule, you can make a mistake as shown here in this right hand side. Here I mistakenly subtracted 2 from 6 and did rest of the operations later. So it was not as per the PEMDAS rule. I didn't follow the PEMDAS rule and I subtracted 2 from 6 before doing other operators, right? So 6 minus 2 is 4. And then afterward, when I did rest of the things even correctly, I came to an answer which is not correct. Okay. So if somebody doesn't know about PEMDAS rule, they can very easily make this mistake. So it is very important to remember this PEMDAS rule, which is parenthesis, exponent, multiplication, subtraction. Now that you have seen a full example, let us move on. I have got a question for you to try on your own. Think carefully and apply PEMDAS step by step. I will reveal the correct answer at the end of the lecture. So stay tuned and check your work. If you want, you can pause the video while you are solving this question. Now coming to fractions and decimals. In this section, we will learn how to add, subtract, multiply and divide both fractions and decimals. When you are adding or subtracting fractions, the key is to make the denominators the same first. Let us look into this example, which is 1 by 4 plus 3 by 8. So in first step, what you should do is that find the least common denominator, LCD. LCD of 4 and 8 is 8. In second step, convert both fractions so they have a denominator of 8. So 1 by 4 should be written as 2 by 8. Now in the step 3, you just add numbers in the numerators. So 2 plus 3 becomes 5. So the answer is 5 by 8. Always remember, same denominator, then add or subtract the numerators. Here is a common mistake to avoid. When adding fractions, don't just add numerators and denominators directly. Like here in this example, I mistakenly added 1 plus 3 to 4 and then 4 plus 8, which were in the denominator, to 12. So this answer is wrong. So never do this mistake. Now let us look at multiplying fractions, one of the easiest operations to handle. The rule is very simple, multiplying the denominators and numerators together. For example, in this example, I multiplied 2 and 4 to get 8 in the numerator and 3 and 5 to get 15 in the denominator. So my answer is 8 by 15. No need to find common denominators and then simplify before or after multiplication if possible. Okay, so it is very straightforward. Okay, now let us go over how to divide fractions. Again, the process is quite simple and follows 4 clear steps which I have written here. The first one is keep the first fraction, then flip the second and then multiply. So we will learn with the help of this example. So 2 by 3 and you have been asked to divide by 4 by 5. 2 by 3 divided by 4 by 5. So first thing I will do is I will keep 2 by 3 as such and then flip the second term. So 4 by 5 will become 5 by 4 and then the third step is multiplication. So I will multiply 2 by 3 and 5 by 4 to get 10 by 12. And then the last step is simplify. So I will simplify this 10 by 12 to 5 by 6. So my answer is 5 by 6. Now coming to adding or subtracting decimals, it is important to line up the decimal points. When you are adding or subtracting, line up the decimal points vertically. If the numbers have a different number of decimal places, just fill in zeros if required. So they are of the same length. This helps us avoid mistakes. Let us look into the example. We are adding 2.3 and 0.07. So think of 2.3 as 2.30. So now there are just same number of points after decimal, 2.30 and 0.07. So you can add up and number comes as 2.37. Multiplication of decimals now. When multiplying decimals, the easiest trick is to ignore the decimal points at first and just multiply the number as if they were whole numbers. Once you have done that, count the total number of decimal points from both the numbers. So let us look into this example. Here we are multiplying 0.2 with 0.4. Think of it as 2 times 4, which gives us 8. Now count the decimal places, one from 0.2 and one from 0.4. So there is a total of 2 decimal places. Okay, so now my answer when multiplying whole number was 8, and I know there should be 2 decimal places, so I will put 0.08 as my final answer. Okay, now the division of decimals. When dividing decimals, the key step is to make the divisor a whole number by moving decimal points. So you have to make the divisor the whole number. But remember, whatever you do to the divisor, you must do same thing to the dividend. So we will learn this with the help of this following example. Here 1.2 is the dividend, that is the number being divided, and 0.3 is the divisor, the number you are dividing by. So what you should do is move the decimal one place to the right in both numbers. So 1.2 should be written as 12 and 0.3 should be written as 3. This gives you 12 by 3 and your answer is 4. Okay, so now here is another question for you to try on your own. It says to evaluate the value of this expression 3.4 plus 0.6 divided by 1 by 5, and then choose the correct answer from the options. So try on your own. Pause the video if you need more time. I will reveal the correct answer at the end of the lecture. Now let us talk about percents. Whether it is calculating discounts, interest or test scores, percent problems show up all the time. So in the next few slides, we will break down exactly what a percent means, how to convert between decimals and fractions, and how to solve percent based word problems quickly and accurately. What is a percent? The word percent literally means per 100. So 25% means 25 out of 100, which is also equal to 0.25 as decimal. Similarly, 60% means 60 out of 100, and in decimal system it is 0.6, and 5% means 5 over 100. You should be able to switch between percent, decimal and fractions very easily, and actually it is a key skill in tests and real life math. So you should be able to do it quite fast. Here is the basic formula which you will use to solve most of the percent problems. Part equals percent over 100 multiplied by whole. So what does that mean? Whole is the total amount you are working with. Percent is the percent rate you are given, and part is the portion or result you are trying to find. So let us apply that to this example, which says what is 25% of 80. So in step 1, what I will do is I will convert 25% to decimal 0.25, and then in step 2 multiply the whole number, which is 80, by 0.25. So my answer will be 20. Here are a few quick tricks to save time on a test day. First, 10% rule. Just move the decimal one place to the left. 10% of 70 means 7. Now you need a 20%, that is simply double the 10% value. So 10% of 150 is 15, so 20% will be double the value of 15, so 30. 5% is the half of the 10%. So 10% of 200 is 20, and our goal is to find 5%, so just half, and it becomes 10. Okay, and for 1% rule, move the decimal 2 places to the left. So 1% of 500 is 5. So master these shortcuts and you will answer percent questions in seconds, and that will be very useful on the test day. Sometimes instead of finding a percent of a number, you are asked a reverse question like 80% is 25% of what number. In this case, you already know the part which is 80, and you are solving for the whole number. Your goal is to find the whole number. So in this particular case, you know the part is 80, so you will divide 80 by 25 divided by 100, which is 0.25, and your answer will be 320. So 80 is 25% of 320. This table shows you some of the most common percent to decimal to fraction conversions. These pop up all the time in questions, and if you have memorized them, you will save valuable seconds. Now try a percent based problem on your own, one of the most common question types on the ACT. This question involves 2% steps, a discount followed by tax. So you take your own time and try it out. I will give you the answer near the end of the lecture. Let us now explore integers and absolute values. Integers include all positive and negative whole numbers as well as 0. Now let us look at how signs affect multiplication and division. A positive times positive gives a positive result. Say 3 times 2 is 6. In negative time, negative also gives the positive results. Say minus 3 times minus 2 is 6. But if one number is positive and other is negative, the result is negative. Say 3 times minus 2 is minus 6, or minus 3 times 2 is minus 6. So these signs rules are very important, especially when you are working with algebraic expressions or equations. Missing a sign can mean getting the whole problem wrong. Now coming to subtraction. Subtraction can be written as adding the opposite. So it means instead of subtracting a number, you can add its negative. For example, 6 minus minus 2 can be written as 6 plus 2, which becomes 8. And also say 5 minus 7, then you can say that 5 plus, and in bracket minus 7, it comes minus 2. This method avoids sign mistakes which are sometimes possible, especially when you are working with long algebraic expressions. Now coming to absolute value. What is absolute value? The absolute value of a number is simply its distance from 0 in the number line. That means it is always positive or 0, never negative. So the absolute value of 5 is 5, and absolute value of minus 5 is also 5, and absolute value of 0 is 0. So it will always be positive. But watch out for a common mistakes. If a negative sign is outside the absolute value symbol, like here, then this symbol, negative symbol, doesn't go away. For example, the negative absolute value of 3 is negative 3, okay, because this sign is outside the absolute value symbol, so it will stay there. Sometimes students make this mistake. So don't drop sign outside absolute value. Say minus of absolute value of minus 4 will be minus 4, not 4. Okay. Similarly, the absolute value of minus 4 plus 1 will be absolute value of minus 3, and that is 3. Now let me test your understanding of integers and absolute values with this quick question. Pause the video if you need more time. I will give the correct answer at the end of this lecture. Now coming to expressions and variables. What are expressions and variables? Expressions are the math phrases made of variables, constants, and operators. Some examples are 2x plus 5 or say 3a minus 4b plus 7. So, these are the examples of the expressions. Remember, expressions don't have an equal sign. They just represent the value that can vary. In an expression, like terms combine. So, now the question comes, what are the like terms? Like terms are the terms with same variable and same exponent. You can combine like terms by adding or subtracting their coefficients. For example, suppose you have 3x plus 2x, they are the like terms, your answer will be 5x. Similarly, 7y minus 4y, you can subtract them, your answer will be 3y. But suppose you have a term say 5x plus 3, you cannot combine them together. They are not the like terms. So, again you can see in this table I have put like terms. Suppose you have a term x, then it is like with 2x or minus 4x. X square, it is like with 5x square, but not with x. All the constants are like with other constants. You can add the constants. Suppose you have 4x plus 2x, you can write 6x. But suppose somebody do 4x plus 2 equal to 6x, that will be wrong. Now coming to distributive property of an expression. The distributive property lets you multiply a term across the parenthesis. You multiply the outside term with each term inside. Suppose you have a and inside the parenthesis you have b plus c, then your answer will be ab and plus ac. So, this is called a distributive property. This works for a subtraction also. For example, if you have a, b minus c, then it will become ab minus ac. Some other examples are say 3 times in the bracket x plus 4, it will be 3x plus 12. Similarly, if you have minus 2 and inside the bracket x minus 5, your final answer will be minus 2x plus 10. Here is another quick question for you to try on your own. Simplify this given expression and find the correct option. You can pause if you need more time. I will give you the correct answer just in next slide. I hope this quick review of pre-algebra and elementary algebra helped you lock in the essentials for standardized math tests like ACT, SAT and others. We will keep building on this in coming videos, so stay tuned. Practice a little bit every day, it adds up. Thanks for watching, and now here are the correct answers to the questions we tackled today.